So now we will talk about cos theta a little bit. Let us take another unit circle. So we will make a lot of unit circles in this chapter. Okay, so this is our x-axis, this is our y-axis, and here this angle is 90 degrees, right? And this is the unit circle that I'm going to take here. Okay, so let me take this radius here. So the radius of this circle is 1 unit, so this length is also 1 unit. And if I drop a perpendicular here, this length up to here, if this angle is theta, will be cos theta, and this length will be sin theta, right? Now you see the points on this circle. For example, if I take this point, for this point the corresponding vertical length will be this much, and what will be the corresponding horizontal length? It will be this much, right? For this point the vertical length will increase, but look at the horizontal, it will decrease, right? So what does it mean is that if this is an angle alpha, right, the coordinates will be cos alpha comma sin alpha. So this length is cos alpha, right? And for this, if I take this angle as beta, so the coordinates will be cos beta comma sin beta. And what will be this length here? This will be cos beta. So when I am increasing the angle from 0 to 90, right, I am increasing the angle because beta is greater than alpha and this angle is greater than this angle, right? So when I am increasing the angle, this vertical length keeps on increasing, that is sine increases from 0 to 90. When I go from 0 to 90, the vertical length keeps on increasing, that is sine increases from 0 to 90 degrees. But look at the horizontal length. This horizontal length was maximum at this point, right? The point is 1 comma 0 and the horizontal length is maximum at this point and is equal to 1 unit, right? So when I go from this 0 to 90 degrees, this horizontal length keeps on decreasing. So cos decreases when I go from 0 to 90 degrees. And how much can it decrease? Like when I come to this point here, this point, the horizontal length becomes 0. So at 90 degrees, cos will become 0. And when was the cos maximum? At 0 degrees. It was equal to 1. So cos 0 degree is equal to 1 and cos 90 is equal to 0. Right? Let me make another diagram, or let us use the eraser here. No shortcuts, let's use another diagram. Okay. So let me make this circle once again. Alright. And this is angle theta. So this length here is cos theta. This length here is sin theta. So horizontal length here is cos and vertical line here is for sin. And these coordinates are cos theta comma sin theta. And we have also learned by now that sine of an angle can be maximum 1 and minimum negative 1. Otherwise it will be between these negative 1 and 1. It can never go out of 1 or beyond 1 or below negative 1, right? This much we have learned. And what about cos? Cos of an angle is also between minus 1 and 1. Okay. Alright. Another thing that we can see here is that coordinates of each and every point on this circle are cos and sine of some angle. Are cos and sine of some angle. And from our knowledge of coordinate geometry, we know that coordinates in the first quadrant, that is here, are positive. X is positive, Y is positive. Right? So cos theta and sine theta both are positive in first quadrant. In second quadrant, we know that x is negative and y coordinate is positive. So we know that cos will be negative in second quadrant and sine will be positive in second quadrant. In third quadrant here, both the coordinates are negative. So cos is negative and sine is negative in third quadrant. And in fourth quadrant, we know that x is positive and y is negative. So we can say cos is positive in fourth quadrant, but sine is negative. So if I ask you, in which quadrant sine is positive? So you can say sine is positive in first quadrant and then it is positive in second quadrant. So in these two quadrants, sine is positive. And when is cos positive? Cos is positive in first and fourth quadrant. Right? Cos is positive in first and fourth quadrant. Once you've learned this, let us think about negative angles. Let us say this is angle theta. This is angle theta. And I draw a line here. And I draw the same angle here. Right? This length and this opening and this opening, these are same. So this angle will not be theta. This will be minus theta. Right? So we take angles in anti-clockwise direction as positive and angles in clockwise direction as negative, right? So now if I make this circle once again, I know that coordinates of these points are cos theta and sine theta, and coordinates of this point are cos of minus theta comma sine of minus theta, right? But I also know that coordinates in this quadrant are positive, that is cos is positive, sine is positive, but quadrant in this fourth quadrant, x coordinate is positive and y coordinate is negative, right? So this is also positive. I can also write it as cos theta. Why? Because if you see the horizontal length for this point and for this point, both these points have this as their horizontal length, or this is cos theta or cos of minus theta. Both are same things, right? But for this point, the vertical length is this, which is above x-axis, and for this point, vertical length is this, which is below x-axis, right? I hope you have understood it. So sine of minus theta is equal to sine of theta in case of magnitude, but in direction it is negative. So I can write it as minus sine theta. Or you can see from the diagram also that this length here is cos of theta or cos of minus theta. For both these points, let me change the color. For both these points, this one and this point, the horizontal length is this, right? So cos of minus theta and cos of theta is one and the same thing. But for this point, the vertical length is this, which is above x-axis, and for this point, vertical length is below x-axis. So sine of minus theta is equal to minus of sine theta, right? Let us proceed further.